Okay, so we start with this system of equations and we want to solve. I'm going to choose to eliminate x. Some people chose to eliminate y because conveniently you got a positive and a negative here. So you could easily multiply this by 5 and this by 2, and your y's would go away. Okay, but I'm going to pick on the x's. I'm going to do -5 times equation 1. It'll give me -10x minus 25y equals 40. And then equation 2 is 10x minus 2y equals 14. In every step, I'm writing out both equations. And if I have to do scratching, multiply this equation by -5, I do it in some other room, preferably some other county. Okay? Seriously, I do it on a separate piece of paper or on a part of the paper that I'm using that I know I'm not going to need for anything else. Okay? This is what we want to see. We want to see this systematic evolution of this system. Okay. So now, in the next step, still going to write down equation 1, but I'm going to write down equation 1 plus equation 2. Equation 1, I look back to the previous step, that's where equation 1 is. And I write down that equation. Then I add the two equations. And I'm going to get -10x and 10x, that's 0. And I'm going to get -27y equals 54. Okay. Now I've written down the equations both times. I'm going to continue this. I'm again going to write down equation 1. Divide equation 2 by -27. If I divide -27y by -27, I get y. If I divide 54 by -27, I get -2. Okay. Now, at this stage, I can always substitute y equals -2 back in here and get x, right? And I'm going to do it a little bit differently. I'm going to write equation 1 plus, 25 there. 25 times equation 2. Now, at this stage, I don't want to work out. I don't want to write 25 times equation 2 because I like equation 2 just the way it is. It gives me my solution, part of my solution. And I don't want to clutter up this process by doing this calculation here. So I'm going to get these two. Okay. Over here somewhere, I'm going to say, okay, let's see. Equation 1 is -10x minus 25y equals 40. 25 times equation 2, well, 25 times y is 25y. 25 times -2 is -50. If I add those two together, I get -10x. -25y and 25y is 0. And over here, I get -10. So now when I write equation 1 plus 25 times equation 2, I write -10x equals -10. And y equals -2. Okay? I don't write this here. It clutters things up. You can't see process anymore. Okay? We do this somewhere else. Somewhere where what's not gonna get in our way. If we can anticipate what's not gonna get in our way. Yeah, when we first work things out, it's a little confusing, but okay. Then what do? I divide equation 1 by -10. -10x divided by -10 is x. -10 divided by -10 is 1. And I write down equation 2, which gives me y equals -2. Okay? This is a process that we're going to use in the assignment. Now, I'm going to go ahead and do all this stuff. All right, does that halfway make sense? It's a more compact way to write this out. Right, the first equation is 2, 5, -8. I just write down the numbers, and I understand that this is a coefficient of x, and this is a coefficient of y, and this is what's on the other side of the equal sign. I write 10, -2, 14. Okay. Then not looking at what I did before. I notice that if I multiply equation 1 by -5, I'm going to get a -10 here to match this 10, so I can add them and get 0. Okay, so I need -5 times equation 1. Now, since I don't have the x's and the y's and the equal sign, I don't have to worry about the distributive law anymore. I automatically get the right numbers. If I just multiply every number by -5, that gives me -10, -25. Then I write down equation 2, which is 10, -2, 14. Okay. Makes sense? So now I can see that these two are going to add up to give me 0. So I'm going to write down equation 1 again. Remember equation 1 refers back to the last step. That's where I have -10, -25, and 40. And in the second step, I have equation 1. In the second row, I have equation 1 plus equation 2, which is 0, -2, 14. It's not 14, 54. And it's not -2, it's -27. Because I'm adding equation 1, equation 2. The -25 and the -2 add up to -27. 40 and 14 add up to 54. Now, this side scratching I did here from the first solution, well, you've seen that we do these things off to the side so everything lines up nice. Okay. Next thing I realized then is, well, if I get a 1 here, then I've got my value 1. So I write down equation 1. Because I don't want to change equation 1 and I don't need to use equation 1 to get a 1 here. I can divide the second row by -27 and I get 0, 1, -2. -27 divided by -27 is 1. 54 divided by -27 is -2. With me? Make sense? Well, takes a little practice. And open math will show you some details too. All right. Now, the next thing I really want to get is if I get rid of that -25, I make that into 0, then I'll have something times x equals something that stands for an equation I can solve for x, right? Okay, so it's easy enough to do. I take equation 1 and add 25 times equation 2. I keep equation 2 for row 2 because row 2 tells me what one of my solutions is. So row 2 is 0, 1, 2. That's not going to change. But when I add 25 times row 1 to row 2, well, maybe I do that off to the side. I don't do it here. I have -10, -25, 40. That's row 1. And 25 times row 2. 25 times 0 is 0. 25 times 1 is 25. 25 times -2 is -50. I add those two together, I get -10, 0, -10. Now, maybe you can do that just by looking at the numbers. 25 times 1 is 25, and I add that here, I'm going to get 0. 25 times -2 is -50. Add that to -40, I get -10. And 25 times 0 is still 0. So I've still got -10 there. So I can just maybe look at these and do it, but it's safer to write out the calculation. I see that I'm adding 25 times row 2 to row 1. So over here, I write out row 1. I write out 25 times row 2. And make sure I can see all that. Yeah, it's all. Then finally, divide row 1 by -10. Gives me a 1 here and a 0 here. And that's -10 divided by 10 is also 1. There I've got a matrix that stands for x equals 1, y equals -2. It says x plus 0y is 1. No x's plus y equals -2. So x is 1, y is -2. Now that totally mimics what I did here. Every step is identical. Okay. And again, none of this side stuff cluttering up the process. Here, I see that I can, by simple step, get a zero here. Okay. And then by another simple step, once I've got the zero here, it's easy to get a one here. So now I've got my solution for y. Then I need a zero here, so I can get some multiple of x equals something. So I get that zero. And then I make that into a one. So my goal is to get 1, 0, 0, 1. Numbers follow using the rules. Okay, can you see that? It's this 1, 0, 0, 1. Okay. Make sense? So I'm going to write down another matrix and ask you to do the same thing. Except I'm going to do one thing first. Okay. I think that'll come out without a fraction. Because I'm trying to avoid fractions because we just want to see what the process is. I'll look at it again and make sure it works. Okay. Now, the one thing I want you to do, I mean, you could multiply this row by 3 and add to this row and eliminate the 6s, right? That'd be a natural thing to do. But I'm going to want to get my 1, 0, 0, 1 as directly as possible, which means I'm going to take row 1. Uh-oh. Change row 1. Okay, I'm going to take row 1. I changed row 1 so I wouldn't get a fraction when you do this, so you won't get a fraction. So let the first step be to divide row 1 by 4. And then you figure out what to do next. Okay, everybody got this first step, so let's write it out. I divide row 1 by 4, 4 divided by 4 is 1, 8 divided by 4 is 2, 20 divided by 4 is 5. Make sure you got 1, 2, 5 there, but I think that's what I'm seeing. Okay, not sure I ever looked at the 5. And you've got row 2, which is 7, -3, 1. Okay. Now, what's our goal? Our goal is 1 here, 0 here, 1 here, and 0 here. And I'm going to write that out a little bigger. Generally, our order is going to be get the 1 here, then get the 0 here, then get the 1 here, then get the 0 here. Okay. So what can you do? These two rows going to end up giving you a 0 here. Another thing, you've already got the 1 here. So you don't want to mess, you don't want to multiply this row by anything or divide it because you don't want to mess up that 1. And remember also, when I added a multiple of one row to another down here, I did it off to the side, did it somewhere else. I'm going to go down to the snack bar and do it and come back. That's okay. Okay, as long as you don't do it in the process. Here, I'm going to erase this when we get down to this point, but right now you're looking to get a zero here, what operation would you do to these two rows in order to get zero here? It's okay, people have a little trouble figuring this out, so we're gonna write out row one because you do not want to mess with that one. How am I going to get a zero here? Well, how about if I do row two minus 7 times row one? Now you see down here how I did row one plus 25 times row two. I just wrote down row one, I wrote 25 times row two, and then I added the two, right? So off to the side someplace, write out how you would do row two minus 7 times row one. Don't write it here. Don't write it below this. Okay. You want to write out everything real explicitly. Remember over here, when I wanted to add row one to 25 times row two, what I do, I came over to the side and I wrote out row one. And I wrote out 25 times row two. I didn't write anything else. I wrote just my directions for what to write down. Then I wrote down row one, which was this, and 25 times row two. Well, 25 times this row two. And then I added them together. And I got something here, okay? So if I do negative 2 minus 7 times row one here, I mean row two minus 7 times row one here, I better write out row two, negative 7 times row one, and then fill in the numbers and put them together. And then what I said was, we want to do row two minus 7 times row one. Might not be totally clear to you why we do that, but we have to do this accurately, okay? In order to do this, we have to write out row two, and we have to write out negative 7 times row one. Okay? We don't write negative 2 minus 7 times row one all at once. We're going to write out row two, which is 7, negative 3, 1. We're going to write out negative 7 times row one. Well, here's row one, 1, 2, 5. If we multiply everything by negative 7, we're going to get negative 7, negative 14, negative 35. Okay? And then we're going to put these two together. What do you get if you have these two rows now? Okay. Now, I'm giving you a method that's going to work, but you have to do every step the way I say. You can adapt it later once you understand what's going on, okay? But it took quite a while for me to convince people if you're going to do row two minus 7 times row one, you write out row two and you write out negative 7 times row one, and you write 2 with a circle, negative 7 times 1 with a circle. So you can always go back and check back in this step if these things are correct, okay? And you reinforce what it is you're doing. You document everything, okay? Now, after you get used to this, you'll be able to maybe take some shortcuts. I don't recommend too many shortcuts on the first assignment, so, okay? Because every time you write this out, you're reinforcing what it is you're doing. Okay, so let's unclutter this a bit. So if we do this, We add these two, we're going to get 0, -17, -34. Okay? And that is row 2 minus 7 times row 1. Row 1 minus 7 times row 2. No, sorry, row 2 minus 7 times row 1. Okay? So I've identified everything that I did here, and it matches now what I've got here. So I can write down 0, -17, -34. Okay, so where am I now? I've got my 1 here. I've got my 0 here. Okay, what's the next thing I need? I need a 1 here. Well, I need a 1 in the second row. There's no multiple of the first row I can add to get a 1 here without messing up my 0. Once I've got that 0 there, I keep it locked in. So what am I going to do? Well, I'm going to do I'm going to divide row 2 by -17. That is, divide every number in row 2 by -17. And I'm not going to change row 1. I could do both things in one step, but that would be a complicated step, and you don't want complicated steps. You want one step at a time. Okay? So I write down row 1 here. What do I get? I write down row 2 minus divided by -17. What do I get here? So again, write down everything that I've done here and then fill it in. Okay? Okay. It's looking a little better. Okay? You don't need to write it off to the side and divide -17 into each of these numbers, but you can if you wish. If you do, just write it off to the side someplace. But you're going to get 0, 1, 2. -17 divided by -17 is definitely 1. And -34 divided by -17 is 2. And we still have the first row, which is 1, 2, 5. I'll give you the step here. Some of you figured it out already. Okay? Most didn't, but some did. Okay? Right there's going to be your step. See why that works. Okay, now again, I'm not saying on all your papers the way I've written out these rules. Of course, I probably want to put a 1 here and 2 here, but after that, I write the operations. And I've written the operation next to the matrix every time. Okay? You really need to do that. So if it doesn't look like this, then kind of missed that idea in your notes, okay? Okay, anyhow, when we do this, well, let's do row 1 minus 2 times row 2. We'll do that off to the side and write down row 1, which is 1, 2, 5. Did leave myself enough room. Again. Plenty of room to write down that stuff. Notes. Okay, we write down row 1, which is 1, 2, 5. We write down row 2, divided by -17. Which gives us, well, you divide 0 by -17, you get 0. You divide no. So let's try once more. Instead of row 1 minus 2 times row 2. It's row 1 minus 2. Say it right. I want to do row 1 minus 2 times row 2. So I want to write down row 1, and then I want to write down -2 times row 2. Okay, -2 times row 2. What's row 2? Row 2 is here. -2 times 0 is 0. -2 times 1 is -2. -2 times 2 is -4. And when I add that up, I get 1, 0, 1. So here's my calculation of 1 minus 2 times row 2. Write out 1 and look at row 2 and write out -2 times all those numbers. And I get 1, 0, 1. And here I've got 0, 1, 1. Okay, this tells me x equals 1 and y equals 1. Now, if I write down the equation here, it's 4x plus 8y equals 20, and 7x minus 3y equals 1. I didn't write my second row down correctly. Row 2 is here at 0, 1, 2. And I was checking x equals 1, y equals 1, and it didn't work. But x equals 1, y equals 2 does work. So what I've done is I've written out the equations, and now I plug in x equals 1 and y equals 2. 4 times 1 is 4, 8 times 2 is 16, 4 and 16 is 20. And this one checks out as well. Okay, so now I know that I've done it right. All right. Well, there's a little more to matrices. There's also matrix addition and multiplication. I'll leave it to open math to show you how to do the matrix addition, which is pretty simple. Okay, matrix multiplication is a little less simple. But I can show you with a simple example. This is a row. Times a column. A row times a column. I take the first number in the row and the first number in the column and I multiply them. And to that I add the second number in the row times the second number in the column. And then the third number in the row times the third number in the column. Now, open math will tell you the same thing, maybe in different words. If this only works if I have numbers in a column to match up with the numbers in the row and vice versa. Everything has to match up. If I get to a number and I get to a number in the row and I'm out of numbers in the column, I can't do the multiplication. Okay, so the row has to have the same length as the column. This row has length 3, column has length 3, so I can match up 3 products. Okay, so that's pretty simple. That makes sense? And this equals 2 minus 12 plus 10, which equals, oh, probably darn, it equals 0. I wasn't trying to make that happen, but it can happen. Okay? Got that? Okay, now. Now I've got 2 rows in 1 column, right? Well, I multiply the first row by the column. So that's negative 18 and 2 is 16. So I write 16 here. Number in the first row multiplied by the column goes in the first row of the product matrix. Then second row times second times the column is 2 times 2 minus 4 times negative 3, which is 4, and 12, which is, doggone, 16. Okay? So I'm getting a 0 here, I'm getting 2 16s here. What? Just the way I made up the numbers. Does that make sense? If I can multiply a row by a column, then I can multiply a matrix consisting of 2 rows by a column. I just multiply the first row by the column and put it first, multiply the second row by the column and put it second. Use the same matrix I had here. But now I'm going to have same column, but I'm going to have different column and a different column. Okay. I can do the first row times the first column. Just like I did over here, I'm going to get 16 and 16 because this matrix is the same as this in the first column is the same as this, right? So we can see I got 16 and 16. Now, so here is the matrix. Well, our first matrix times our first column. Now, our first row times our second column. Well, the first row is still 1, 6. Our second column is 1, 5. So 1 times 1 is 1, 6 times 5 is 30. So that gives us 31. Then I multiply row 1 times column 2. Row 1, row 2 times column 2. I did row 1 times column 2. Now row 2 times column 2. Okay, so I do this row by this column, and then this row by the same column. That's going to give me 2 minus 20, which is negative 18. So I'm getting 31 and negative 18. This row times this column gives me 31. This row times this column gives me negative 18. 1 times column 2 is going to go in, well, it's going to go here. I'll say how that works. We get 31 and negative 18. Now, where did 31 come from? It came from row 1 and column 2. Now, where is it in this product matrix? It's in the first row and it's in the second column. So if it comes from the first row and the second column, it goes in the first row and the second column. If it's the second row times the second column, it goes in the second row, second column. Similarly then, one times column 3 is 1, 6, multiplied by negative 3, 4. And then I can write out the deep, well, yeah, it's negative 3 plus 24 equals 21. And row 2 times column 3 is 2, negative 4, multiplied by negative 3, 4, which is negative 6 minus 16, which is negative 22. Okay, so row 1 times column 3 is going to go in row 1 of the product matrix and in the third column. Now we don't have a third column yet. We're going to start with the 21 here. Now this is in first row, third column, because it came from the first row and the third column. Row 2 times column 3 gives us negative 22. Well, that'll go in the second row and the third column. And if I did my arithmetic right, that's how you multiply these two matrices. Does it make sense? You just gotta practice it, look at it, write it out carefully. Okay. And I will maybe write it out the way I've written it out here. But if you see something you like better in open math, that's fine too. Okay. All right. Now, this assignment is due tomorrow. Might take a little digesting. So I'll say if you get half of it done or close to half of it, I'll give you a little extension and won't be due until Monday. Okay. But you got to get at least half of it done. Otherwise, 2.5 credit page. Okay.